Welcome to the video for SmartTut 6. We will firstly be looking at some exercises based on your binomial notes. The first problem we're looking at says, find the coefficient of x squared in x to the power of 2 over 3 plus 1 over root x all to the power of 10. Okay, so what we want to do is we want to use the binomial theorem in order to write this in a way that we can see what it would look like when it is expanded. Okay, so let's start with that. We start with x to the 2 over 3 plus, and I'm just going to write it as x to the minus a half all to the power 10. Then I'm using the binomial theorem to write it as the sum as n goes from 0 up to 10 of 10 choose n, and then I take my first term x to the 2 over 3 and I write that to the 10 minus n, and then I take my second term which is x to the minus a half. Just remember, if this were negative, it would be important to include that in your term. So, but here I just have x to the minus a half, and that's going to be to the n. Now, what are we asked for? We are asked for the coefficient of x squared. Okay, so all we want to do is we want to find out for what n do we get an x squared when we multiply these two brackets. So let's see what we get when we multiply them. So firstly, let's multiply the exponents in. Then we get x to the 20 over 3 minus 2n over 3. And we get x to the minus a half n, which then gives us x to the 20 over 3 minus 2n over 3 minus a half n. We want to know when this is equal to x squared. So that means that exponent has to equal 2. So 20 over 3 minus 2n over 3 minus a half n, I'm just going to write it as n over 2, has to equal 2. So I'm going to take all of my terms containing an n to the right and all of my terms not containing an n to the left. So then on the left I have 20 over 3 minus 2, but I'm also just going to write my 2 as 6 over 3. So that I have 20 minus 6 over 3. On the right hand side, I'm going to have 2n over 3 plus n over 2. But I can write all of that on one denominator. So I can write it on 6. So it's going to become 4n over 6 plus 3n over 6. Then we can divide both sides by 2. Then we can divide both sides by 3. So I'm only left with a 2 there. Then I have 14 equals 4n plus 3n, which is 7n over 2. So I have 28 equals 7n. So n equals 4. So in other words, when n equals 4, and we multiply these two terms, we get an x squared, and the coefficient of that x squared will be 10 choose 4. So the coefficient that we were looking for is going to be 10 choose 4. And that's it. The next problem says solve for x. So we have the sum as n goes from 0 up to 5 of 5 choose n, x to the 5 minus 2n equals 32. What we want to do here is we want to try and write our left hand side as the sum of two terms all to the power of 5 equals 32. And then from that, we want to solve for x. Okay, so in order to do that, we have to use the binomial theorem to be able to write the left-hand side as the sum of two terms to the power of 5. So we need our left-hand side in this form. Okay, so that's all we're going to do. We're going to manipulate our left-hand side so that we get it into the form we need. So I have the sum from 0 to 5 of 5 choose n. Then I have x to the 5 minus 2n. But I need x to the 5 minus n, right? If I compare it to what I have there, I have n minus k. So this means that if I compare it to what I have here, I have a 5 where I have an n in this case, and I have an n where I have a k in that case. So I need to write my x to the 5 minus n, but then I still have an x to the minus n left, and that equals 32. But if I look at what I have here, I have a y to the k. In other words, I need something here which is going to be something to the power of n. Well, it's pretty easy to write this as something to the power of n. This will simply become, so I have the sum from 0 to 5 of 5 choose n, x to the 5 minus n, and then I have 1 over x to the power of n equals 32. And now I have my left-hand side in the form I wanted, and therefore I can write it by using the binomial theorem as x plus 1 over x to the 5 equals 32. And now I can simply solve for x. So let's write the left-hand side as x squared plus 1 over x equals, then I'm going to take the fifth root on both sides. So I have 2. Then I have x squared plus 1 equals 2x. So x squared minus 2x plus 1 equals 0. So x minus 1 squared equals 0, which means that x equals 1. And that's what I wanted to do. I wanted to solve for x. We are now looking at exercises based on the proofs notes that you have. And the first one says, show by induction that 1 plus 2 plus 3 all the way up to plus n equals n multiplied by n plus 1 divided by 2. So we are going to follow our induction steps. Step number 1 is we are going to check whether this statement holds when n equals 1. So the left-hand side will then simply be equal to 1. The right-hand side will be equal to 1 times 1 plus 1 divided by 2, which is 2 divided by 2, which is 1. So our left-hand side equals our right-hand side, and it therefore indeed does hold when n equals 1. Step 2 of the induction process is to assume this statement is true for n equals k. So I'm going to call this my induction step. And I'm going to assume that it's true for n equals k. So in other words, I assume that when I have 1 plus 2 plus 3 plus all the way up to plus k, that I have k multiplied by k plus 1 over 2. And I call that my induction hypothesis. Now, for the final step. For the final step, I now want to prove that it's true when n equals k plus 1. In other words, what I want to prove is that 1 plus 2 plus all the way up to plus k plus 1 is going to equal, so instead of just k, I'm going to have k plus 1, and then I'll have k plus 1, which is just k plus 2, divided by 2. This is what I want to prove. So what I'm going to do is I'm going to start with my left-hand side, and I want to get to the right-hand side. So my left-hand side is 1 plus 2 plus 3 all the way up to plus k plus 1 k plus 1. Now, from my induction hypothesis, I know that this is equal to k multiplied by k plus 1 over 2. So I'm going to replace this by k multiplied by k plus 1 over 2. So I'm going to say this then equals k multiplied by k plus 1 over 2. And then I still have plus my k plus 1. So this is where I apply my induction hypothesis. Now, I'm going to simplify. So let's write this as k squared plus k plus 2k plus 2 over 2, which is k squared plus 3k plus 2 over 2, which is k plus 1 multiplied by k plus 2 over 2, which equals the right-hand side. So we've proven what we wanted to prove. We've proven that it is true when n equals k plus 1, and therefore that means that it is true for all n. The next exercise says, show by induction that n to the 5 minus n is always divisible by 5. Once again, we apply our same induction steps. So we start off, we look at n equals 1. For n equals 1, we get 1 to the 5 minus 1, which is 1 minus 1, which is 0, which is the same as 5 multiplied by 0. So therefore, it is indeed true that when n equals 1, n to the 5 minus n is divisible by 5. Now, we are going to assume that it's true for n equals k. What does that mean if we assume that? So that means that k to the 5 minus k has to be divisible by 5. That means that it has to be possible to write it as a multiple of 5. So we have to take 5 and multiply it by some integer, and then we get k to the 5 minus k. So it has to be possible to write it as 5 times m for some integer m. And this is my induction hypothesis again. Now, the next step is I want to prove that it's true for n equals k plus 1. In other words, I want to prove that k plus 1 to the 5 minus k plus 1 is divisible by 5. So let's take that. So we have k plus 1 to the 5 minus k plus 1. I'm going to expand it. So I'm just going to use Pascal's triangle to expand that. Let's quickly just write the triangle down. Two, 3, 3, 4, 6, 4, 5, 10, 10, 5. So when I expand my first bracket, I'm going to get k to the 5 plus 5k to the 4 plus 10k to the 3 plus 10k squared plus 5k plus 1. And then I still have my minus k plus 1. So it's going to be minus k minus 1. So what I want to try and do is I want to be able to use my induction hypothesis somewhere in this step. My induction hypothesis says that k to the 5 minus k equals 5m. Let's see if I can find a k to the 5 minus k here. Well, I have a k to the 5 and I have a k there. So what I'm going to do is, firstly, I'm just going to cancel that plus 1 and minus 1. And then I have k to the 5 minus k plus 5k to the 4 plus 10k to the 3 plus 10k squared plus 5k. I'm just quickly going to erase this triangle to make a bit of more space. So this, I said I can replace it by 5m. So what I have now is I have 5m plus, and then from all of these remaining terms, I can take out a common factor of 5. Because remember, our goal is to show that what we have on the left-hand side can be written as a multiple of 5. So if we take out a common factor of 5 there, then we are left with k to the 4 plus 2k cubed plus 2k squared plus k. And then we can take out a common multiple of 5 from here and there. So then I get 5 multiplied by m plus k to the 4 plus 2k cubed plus 2k squared plus k. And this is what I wanted to show. I wanted to show that I can write the left-hand side as an integer multiple of 5. And m is an integer, k to the 4 is an integer, 2k cubed is an integer, 2k squared is an integer, and k is an integer. So we have proven what we wanted to show. So k plus 1 to the 5 minus k plus 1 is divisible by 5. And therefore, it means that the statement that n to the 5 minus n is divisible by 5 is always true. Next, let's just talk about some of the other problems in the tutorial. If we look at number 6, it says that suppose p is a prime number and that 1 is less than or equal to k, which is less than or equal to p minus 1. Show that p choose k is divisible by p. So, what does it mean for something to be divisible by p? This is similar to the previous problem we did. It means that it has to be possible to write that something as some integer value, say q, multiplied by p. So in other words, to show that p choose k is divisible by p, we have to show that p choose k is just some integer multiple of p. So simply use the definition of what this is equal to, write it out, and see if from there you are able to write it as p multiplied by some value. It can be the product of things, the quotient of things, but that whatever you have p multiplied by, that has to be an integer. And then you have proven that p choose k is indeed an integer multiple of p. So it is divisible by p. Next, for number 7, it says prove that for any positive integer n, 2n choose n equals 2 multiplied by 2n minus 1 choose n minus 1. So the hint here will be, just look at your right hand side and write out what it equals. So it equals 2, then you have 2n minus 1 factorial over n minus 1 factorial multiplied by 2n minus 1 minus n minus 1 factorial. So the hint here is to start with your left hand side, write out what it equals, then manipulate it so that you get to this right hand side, and then you have proven what you needed to prove. For the rest of the problems, it is still induction that you have to apply. So for all of these problems, follow your induction steps. So the first step is show that it's true when n equals 1. The next step is assume that it's true when n equals k, and write down what you get, and you get an induction hypothesis. The final step is you want to prove that it's true when n equals k plus 1. In other words, you want to try and use your induction hypothesis where you assume that it's true when n equals k, and you want to use it in proving that it's true when n equals k plus 1. This is the end of this week's video.